Hello, welcome to today's class. Today we'll be solving these two equations, simultaneous linear equations, using substitution method. So this is my equation 1 and this equation 2. So let's start. We say solution. I'll write in my equations first. 4x minus y equal to 11 as equation 1, and then we have 5x plus 2y equal to 4 as my equation 2. The first thing we have to do here is to make our x or our y the subject of formula in equation 1. So I want to make x the subject of the formula. So I'm going to bring up my equation 1, that's 4x minus y equal to 11. This is my equation 1. And now I'm going to make x the subject of the formula. What is holding x here? We have the y and 4. So we're going to send y over to the other side. So we have on this side left 4x equal to, this is 11. Y crossover is received as plus y. At this point, what we do? We divide both sides by 4. Divide both sides by 4. So we have here 4x all over 4 equal to 11 plus y all over 4. So 4 cancels 4. We have our x equal to 11 plus y 4. I'll name this equation 3. Now that we've gotten the value of x as 11 plus y all over 4, we can impute this value now into equation 2. So we say impute x into equation 2. Now what is our equation 2? Our equation 2 was 5x plus 2y equal to 4. So that means wherever I see x, I'm going to write 11 plus y all over 4. So this is 5 multiplying 11 plus y all over 4 plus 2y equal to 4. Now this 5 outside is going to multiply the numerators of this fraction. 5 times 11 will be 55. 5 times y, that will be plus 5y all over 4 plus 2y equal to 4. Now at this point, this is a fraction, this is not a fraction. So I can make both of them fractions and say over 1. Now this is a fraction, this is a fraction. I can now take the LCM of denominators. And now the LCM of 4 and 1 is 4. This LCM work on this first fraction as 4 divided by 4, which is 1. That one multiply all of this. So this will be 1 times 55, 55, plus 1 times 5y, 5y. We are done using this to work on the first fraction. Now we go to the next fraction. 4 divided by 1 is 4. 4 times 2, that's 8y, all equal to 4. Now we have successfully converted this to a single fraction. Now here we can see that we have 5y plus 8y. That's going to give us 55 plus 13y all over 4 equal to 4. Now looking at this, we have here a fraction and we have here a whole number. So we can simply make this other side a fraction by dividing it by 1. And then we cross multiply. That means this 1 will go up and multiply the numerator of this fraction. And here too, the denominator here will go up and multiply the numerator of this fraction. So let's go. 1 multiplying 55 will still be 55. 1 multiplying 13 will still be 13y equal to 4 times 4 will be what? 16. So at this point, we're going to say, here we have 55. Here we have 13y, and here we have 16. So what do? Let's collect like terms. Collect like terms. That simply means 55 is going to cross over to meet its kind here. And we're going to have only 13y here. So we have 13y equal to 16. This is positive 55. If it crosses over, it becomes negative. That will be minus 55. So we have here 13y equal to 16 minus 55 will be minus 39. So we can now say, what exactly is holding y? Here, that's 13. What's connecting it? Times. So we're going to use the opening of times with what? Divide. So we say divide both sides by 13. Divide both sides. So this will be 13y. This 13y here divided by 13 equal to minus 39 divided by 13. So 13 cancels 13. Our y equal to 13 goes here. That will be 3 minus 3. Now that we've gotten y, what are we going to do with the value of y? We are going to impute this value into our equation 3. So we say impute y into equation 3. And our equation 3, remember, was x equal to 11 plus y all over 4. So our x now will be equal to 11. This is plus y, that's positive y. And we know that y was negative 3. So this becomes minus 3 all over 4. 11 minus 3 is going to give us 8 over 4. 4 goes here, 2. So our x equal to 2. So with this, we have gotten the value of x as 2 and y as minus 3. So this is how we use substitution method to solve for the value of unknowns x and y in simultaneous linear equations. Please do well to subscribe to our channel, to like this video, to comment and share. Thank you.